Good day friends, we'll start with our lectures on the subject engineering geology. Before that, I would like to introduce myself. I am Professor Vivek Kulkarni. So we'll be dealing with the subject engineering geology for second year AC Civil 2019 pattern. So Unit 1 is Introduction to Geology. So, so in general geology, mineralogy and petrology. In introduction to the subject, geology deals with the study of Earth and its features such as surface, origin, composition, structure and its inhabitants of the Earth. Scope of geology. So geology is of practical importance to mankind. It helps to things like coal, petroleum and mineral, atomic fuels and civil engineering for various projects such as dams, tunnels, foundations, bridges, etc. Now general geology. Now the Earth as a planet. The Earth is a planet, so it is a member of the solar system and it moves around the Earth, Sun in elliptical orbit. It also rotates about in one axis. Earth is considered as the inner planet of the solar system. It is believed that the age of the Earth is about 4,600 million years. Then subdivision or branches of geology. Physical geology. It is concerned with the work of natural processes which brings about the changes of the Earth's surface. Petrology. It deals with the composition, structure and origin of the rock. Mineralogy. It includes the study of mineral composition, structure, appearance, stability, occurrence and association. Structural geology. It deals with the study of the structure of the rock in the earth crust. Stratigraphy. It is the science of description, correlation and classification of strata in sedimentary rocks and interpretation of the deposition environment of those strata. Paleontology. It is the science of fossils of ancient life forms and their evolution. Biology of rock. In historical geology, it deals with the study of stratigraphy and paleontology. It is included under the historical geology. It shows the land, seas, climate, and early life on Earth. Economic geology. The economic geology deals with the study of minerals, ores, and fossil fuels for economic importance. Mining geology. It concerns with the study of application of geology for mining purpose. And engineering geology, as our subject, it includes the study of application of geology to civil engineering. So, internal and general composition of Earth. The Earth is made up of three layers: the crust, the mantle, and the core. The crust, it is the outermost or outside layer of the Earth. As you can see in the section, a small section of Earth. So this is the crust section, showing some bluish. Okay. So this is the outside layer of that and made up of solid rock, mostly basalt and granite. So there are two types of crust. One is oceanic crust, which deals with water, and continental crust that is deals with land. Oceanic crust is denser and inner and thinner and mainly composed of basalt. So oceanic crust is denser and continental crust is less dense, thicker and mainly composed of granite. So it contributes to 1% of Earth biomass. So Earth crust is only 1% of the total weight of the Earth. So the second layer, the mantle lies below the crust. So this is the mantle. So this lies below the crust and is up to 2,900 km thick. It consists of hot, dense iron and magnesium rich solid rocks. The crust and the upper part of the mantle makes the lithosphere, which is broken into plates, both large and small. It makes about 31% of the earth mass. Now the core, it is the internal part. So this is the core, internal part, innermost layer of the earth. So it is the center of the earth and is made of two parts, the liquid and an outer core and the solid inner core. The outer core is made of nickel, iron and molten rock. The temperature here can reach up to 50,000 degrees Celsius. It contributes to about 68% of the Earth's mass. Now next is rock cycle. Rock cycle is a group of changes. Now, igneous rocks can change to sedimentary. Igneous can change to sedimentary, and sedimentary can change into metamorphic rock. These are the types of rocks. A metamorphic rock again to igneous rocks. Okay, and it can also change to sedimentary also, sedimentary rock also. Igneous rocks are formed when magma cools and makes crystal. Now on Earth's surface, wind and water can break rock into pieces. They can also carry rock pieces to another place. So wind and water are the main agents of the changes in geology. Usually the rock pieces called sediments drop from the wind or water to make a layer. The layer can be buried under the one layer of sediment. After a long time, sediments can be cemented together to make a sedimentary rocks. In this way, igneous rocks can become sedimentary rocks. All rocks can be heated. Baked rock does not melt, but it does change. It forms crystal. If it has crystals already, it forms a larger crystal. Because this rock changes, it is called metamorphic rock. The rock cycle continues. Mountains made of metamorphic rocks can be broken up and washed away by streams. New sediments from these mountains can make new sedimentary rocks. The rock cycle never stops. So, introduction to mineralogy. Mineralogy is a naturally occurring homogeneous solid with a definite but generally not fixed chemical composition and an ordered atomic arrangement. It is usually formed by inorganic processes. They have a common set of constant physical properties. The minerals may be divided into two broad groups. One is rock-forming minerals and second one is ore-forming minerals. Rock-forming minerals are found in the abundance in the rock on the earth. Ore-forming minerals does not found in abundance in rocks. So these are our mineral groups, and these are examples: oxides, mainly quartz, magnetite, hematite, limonite, etc. Silicate group: feldspar, mica, hornblende, augite, and olivine. Carbonates: calcites, dolomite, siderite, etc. Sulfides: pyrite, galena, sphalerite, etc. Sulfates: gypsum, and chlorides: rock salt, etc. There are about 2000 minerals that exist, but most of them are rare. Only 29 minerals occur in common. The common types of minerals and their formation is given in the table above. So the table which we are seeing is a common type of mineral. Then physical properties of minerals. This type this can be determined by inspection or simple test. They are important in identification of minerals. The main physical properties are as follows. First one is color. So color is often useful but should not be relied upon. Different minerals may be of the same color. Real gold as seen in figure. Additionally, some minerals come in many different colors. Quartz, for example, may be clear white or grey, brown, yellow, pink, red or orange. So color can help but do not rely on color as the determining property. The figure above shows one sample of quartz that is colorless and the other quartz is purple. A tiny amount of iron makes the quartz purple. So many minerals have color by chemical impurities. So color is the impurity in the mineral. Now stick is the color of minerals powder. So when mineral is broken down to powder, with the color which we get is called as stick. Stick is more reliable property than color because stick does not vary. Minerals that are the same color may have different color sticks. Many minerals such as quartz do not have stick. Gold which has golden yellow stick. So this is the stick process. Okay. To check stick, scrape the minerals across an unglazed porcelain plate. This is unglazed porcelain plate and we are scraping the mineral against it. Yellow gold pyrite has a blackish stick. Another indicator that pyrite is not gold, which has golden yellow stick. So luster describes the reflection of light of a mineral surface. Mineralogists have special terms to describe luster. One simple way to classify luster is based on whether the mineral is metallic or non-metallic. Minerals that are opaque and shiny such as pyrite have metallic luster. Minerals such as quartz have non-metallic luster. A metallic luster means shiny like polished metal. For example, clean polished pieces of chrome, steel, titanium, copper and brass all exhibit metallic luster, as do many other minerals. Of the non-metallic lusters, glass is the most common and means the surface of the mineral reflects light like glass. So let's see uh, 6 types of non-metallic luster. So adamantine, they have sparkly appearance, earthy, dull, they look like clay-like, pearly, pearl-like, resinous, like resin such as tree sap, then silky, soft-looking, long fibers, and vitreous means glassy. Next property, hardness. Hardness is the strength with which mineral resists its surface being scraped or punctured. In working with the hand samples without specialized tools, mineral hardness is specified by Mohs scale of hardness or Mohs hardness scale. The Mohs hardness scale is based on 10 reference minerals from talc to the salt. Talc is the softest, which has a Mohs hardness of 1, to diamond is the hardest with the Mohs hardness of 10. It is relatively or non-linear linear scale. A hardness of 2.5 means that the mineral is harder than gypsum, Mohs hardness of 2, and softer than calcite, that is Mohs hardness of 3. To compare the hardness of two minerals, see which mineral scratches the surface of the other. So Mohs scale of hardness. First one, talc, that is index mineral is talc, then 2 gypsum. Okay. But if we rub gypsum by on our nails, fingernail, we get a hardness of 2.5. Calcite 3, 3.5 pure untarnished copper. Thorite 4, phosphor 5. The stainless steel has a hardness of 5 to 5.5. Glass has a hardness of 5.5 to 6. And apatite has a hardness of 6 to 6.5. So 6 to 6.5 hardness still 5. The seventh one is quartz, 8th one is topaz, 9th one is corundum, and 10th one is the diamond, the hardest of the mineral. Cleavage. Now cleavage is the tendency. Cleavage is the tendency of minerals to break along certain planes to make smooth surfaces. So halide breaks between layers of sodium and chlorine to form tubes with smooth surfaces. A mineral that naturally breaks into perfectly flat surfaces exhibiting cleavage. Not all minerals have cleavage. A cleavage represents a direction of thickness in the crystal lattice. Cleavage surfaces can be distinguished by how they consistently reflect light, polished, smooth, and even. Fracture. Fracture is a break in mineral that is not along a cleavage plane. Fracture is not always the same in the same mineral because fracture is not determined by structure of the mineral. Minerals may have characteristics as shown in the figure below. Metals usually fracture into jagged edges. If a mineral splinters like wood, it may be fibrous. Some minerals such as quartz form smooth surfaces when they fracture. Silicates and non-silicates minerals. Many different kinds of minerals exist. They, they can however be divided into broad classes, the silicate and non-silicate minerals. The silicates are more abundant, although not non-silicates are very common as well. Not only do the two exhibit differences in their composition, but also in their structure. The structure of silicates tends to be more complex, while the structure of non-silicates features a great deal of variability. Composition of silicates. Silicates are divided into different groups based on their structure. The first of these is neosilicates, which are formed from atoms arranged in four-sided shapes called tetrahedra, with four oxygens on each unit that can connect with atoms arranged in other shapes containing positively charged ions, commonly called as cations or cations, like aluminum or potassium. Sorosilicates are unit of two tetrahedra that share one oxygen atom, while cyclosilicates have rings of tetrahedra, each tetrahedron sharing two oxygen atoms with its neighbors. Cations or cations can become trapped in the center of these rings. Inosilicates have continuous chains of tetrahedral units, each of which two each of which shares two oxygens with its neighbors. Phyllosilicates have sheets of tetrahedra, each of them sharing three oxygens with immediate neighbors. The sheets are separated by other. Finally, tetrosilicates have a continuous framework of tetrahedra, each sharing all four groups, and arrangements and cations can be trapped in the spaces between tetrahedra, oxygen atoms within its neighbors. Now next topic, rock forming minerals. Rocks consist of minerals. A mineral is a material that occurs naturally and is generally strong, crystalline, stable, and inorganic at room temperature. There are many known mineral species, but the vast majority of rocks are formed by combination of a few common minerals called rock forming minerals. The minerals that form rocks are feldspar, quartz, amphiboles, mica, olivine, granite, calcite, pyroxene. These are various types of minerals. It is potassium feldspar, this is plagioclase feldspar, quartz, then muscovite, calcite, dolomite, magnesite, then andalusite, sillimanite, kyanite, these are amphiboles, contains magnesium, iron, calcium, sodium, along with silicon and oxygen. Then pyroxene contains magnesium, iron, calcium, aluminum with combination of silicon trioxide. Olivine, magnesium, iron with combination of silicon silicon tetroxide. These are biotite, that is magnesium, ferrous, potassium, aluminum in combination with silicon oxides. garnet, iron, magnesium, calcium, and magnesium in with aluminum silicon oxide, magnetite and hematite. We will stop here for our first lecture on engineering geology. Okay, we will continue with our lecture, second lecture in our next part. Thank you very much.